Okay, so next year, class 10 science, chapter 2, acids, bases and salts, video 8. Okay, but before we go to video 8, let us go to the previous one, video 7. There is a correction that needs to be met here. So question 66.1, there ammonium chloride NH4Cl may be obtained from the acid. Now, as we said, acid comes from the negative part of the salt. That means the back part, this Cl. Negative radical will give you the clue for acid, from where the acid is coming. So Cl means the acid having that one is HCl, hydrochloric acid. That was correct, I think. And base comes from the positive part. This one, front part. Therefore, this positive radical is also called basic radical, right? So this base having this positive radical NH4 is nothing but ammonium hydroxide. So this is the base, okay? In the previous yesterday video 7, we made a mistake of writing here NH4 Cl. So correct it, okay? This is wrong. Rub it out and write this one. Okay, now we go to video 8, okay? The last video before the TEST-2D, I think. So look here now. Question 71 on your tuition note. And if you don't have tuition note also, it is the activity 2.14, textbook page 30, okay? You collect the following salt samples: sodium chloride, potassium nitrate, aluminum chloride, zinc sulfate, copper sulfate. But we have just cancelled out copper sulfate. I feel it will not be necessary, so just cancel it out, though it's on page 30 of your text. Sodium acetate, sodium carbonate, and sodium hydrogen carbonate also. Just cancel it out, okay? The remaining will be enough to understand this. This is an important activity. We're going to first, number A, identify the acid and base used to form each of these salts, okay? So let us start with that. Okay, so for the first salt, following salt samples here, sodium chloride. Okay, let us just write the formula directly. Sodium chloride is NaCl. So as we learned even yesterday, this is sort of repetition of yesterday's only, but it is good because it's the chapter on acids, bases and salts. And we know that salts are derived when acid react with base, then we get the substance called salt. And then usually we get water, right? So salt is a substance, in other words, like sodium chloride, which is formed when one acid react with a base. So which is the base? Which is the acid? That's what A is asking us to do. So as we learned yesterday, the acid part comes from the negative part of the salt. So this is the part. So the acid here is, acid will be HCl, and then the base will be here from the positive part, because the base, which is the base, the clue comes from the positive, the front part of the formula. So Na, the base having that positive radical Na plus is sodium hydroxide, the famous base. So let us do that, continue and do the next salt, sodium chloride, then potassium nitrate, KNO3. So the acid will be from the negative part, which is, we remember, a nitric acid, HNO3, and the base will be, okay, we need not write that, repeat the same thing. The base will come from the positive part, K, so the base having K is potassium hydroxide. Then next, aluminum chloride, so Al3 plus, Cl1, so 1 need not be shifted, 3 will go to the back. So acid will come from the negative part, Cl. The only acid having that is this one, just like this Cl. And the base is coming from the positive part. The base having the positive radical Al3 plus is aluminum hydroxide. So hydroxide, this 3 valency will go at the back of OH after bracket only. So next here, zinc sulfate. So here zinc sulfate means Zn2 plus, SO4 2 minus, or 2 cancel. Then the acid comes from the negative part. So let us write here, the only acid having that SO4 radical is sulfuric acid. And the base comes from the positive part, the positive, I'll underline single, okay? So that is zinc hydroxide, the base. So 2 will go here because valency of zinc ion is 2 plus. So this is the base. Now most of the bases contain OH because by definition also a base is a substance that release hydroxide ion in water, right? So here next zinc sulfate, then copper sulfate we have opted it out, so sodium acetate. So this is a rare formula. Listen to this. Sodium acetate formula is CH3 COONA. We know from a start that Na is plus and CH3 COO minus is acetate ion negative. Normally all the compounds are written with positive first, Na plus first, K plus, Al plus, and negative second part, Cl minus, NO3 minus. But this is an exception. Exception means different from the others. So here in this salt, the negative part is written first, unlike the remaining salts. Very rare exception, and the positive is written at the back. Remember that. So remember the acid will come from the negative part. So remember your negative is not this now. This is the one, CH3COO minus. So the only acid having that acetate ion minus is acetic acid, CH3COOH. And the base is here, coming from the positive part, just like the remaining, it comes from positive part. Here the positive is at the back, here front. That's the difference. So the base having positive Na is sodium hydroxide. Then next here, we have sodium carbonate. So sodium carbonate is a salt, and which is the acid from which is the acid from which it is formed, the negative part, CO3 minus. The only acid having that CO3 minus radical carbonate ion is carbonic acid, H2CO3. Then the base comes from the positive part. As you see, positive part is Na, just like this. So it will be the same base, NaOH, or it will be the same base as this, NaOH, because the positive is same here. Then next, so those are the ones, 1, 2, 3, 4, 5, 6 salts we have picked out, and in each cases we have found out which is the acid and base from which the salt was derived, meaning which is the acid that reacted with which base to give you this salt. In other words, this acid plus this base gave you this salt. Okay, remember that salts are substances formed when an acid reacts with a base. In each of these salts, we are learning to identify which was the acid and which was the base taken to react to get the salt, sodium chloride, like that in each cases. This is an important activity, okay, because the chapter itself is acids, bases and salts. Okay, now we'll go to the next activity, that is B. This is very important. 6 salts we have picked up, so we're going to have to do 6 equations. So B says here, follow me closely, write the balanced chemical equation for each of the acid-base reactions for the above salts, taking one by one. So let us take the first one, which is here, sodium chloride. So we can write the formula, sodium chloride, NaCl. This is the salt. Now we'll know how to identify the acid. It comes from the negative part, so it is HCl. And right from the extreme left, okay, we're going to learn to write chemical equations. This C should be capital, same size with this one. And acid means usually dissolve in water, so we may want to write AQ, meaning dissolve in water, which is good to write, okay? So this is right below that your name, hydrochloric acid, okay? React with the base, the clue comes from positive Na plus. So the only base having that Na plus is sodium hydroxide, NaOH. Again, dissolve in water. So it's right there. The name also below it. That really helps you to get comfortable with chemical equations and formulas and all, okay? So when this react with this, how is this salt formed? So we're going to write a balanced chemical equation for this. Now for this one, there is nothing so difficult about it. Just mark the positive Na plus will combine not with H plus. Plus can't combine, so the negative radical box it. So we can follow a trick. These 2 boxes join means you're going to get a correct compound. So this box is formed by these 2 boxes. And now we have to write the name looking at the formula. So remember your starter, and what is the name of this compound? Yes, Na is sodium ion, so sodium. Cl is chloride ion, Cl minus, so sodium chloride. We won't write ion like that in the compound, okay? So this compound is the sodium chloride, and this is the salt. So So here we see that this acid has reacted with this base to give you this salt, sodium chloride. And then now look at the atoms outside of the box. Here H and one more H, so 2, H2. And then one single O means we're going to get a correct compound, and this is nothing but your water. So exactly balanced, because we took the boxes, exact fitting. Outside boxes, exactly we got this. So the number of atoms on the left side and right side are equal. That is called balanced chemical equation. Okay. Now this balanced chemical equation follows a principle called, if you want to write, principle of atom conservation. Principle of atom conservation, which says that number of each type of atoms in a chemical equation, each type of atoms, number of each type of atoms on the left side of the arrow equation should be equal to the number of atom on the right side, each atom. That means one H here, one more here on the left side, 2H, right side should also exactly have 2H, no extra, no lesser. That is called principle of atom conservation. Balanced chemical equation is also called principle of atom conservation, which says that number of each atoms that are on the left side, total number, should be equal to the number of atoms on the right side. Okay, so that is called balancing equation or principle of atom conservation, or in other words, balancing equation comes by following the principle of atom conservation. Okay, so let us do the next one. Here, the second one, here we can see here the potassium nitrate. So we may want to write the formula once. This is the salt. Now the acid, as we said, comes from the negative part. So this is the NO3 minus. Double tick will do that. So the only acid having that NO3 we now know is HNO3. Acid usually dissolve in water to release hydrogen ion. So AQ we want, it's good to write that. So write the name of this acid, which is good, nitric acid. Okay, making sure that you write from the extreme left, one name up and down, because we need a lot of space on the right side now, because we're going to form equation. And the single tick will mean the base, let us say, plus. The only base comes from the clue of the positive radical K plus. The base having K plus is the famous base, potassium hydroxide dissolved in water. So this is your potassium. And then hydroxide you write below it. So once you form this, you get on the right side what salt. Here also, just like we did just now, we can follow the same trick. K positive, NO3 minus. When you combine this, you get KNO3, which is a correct formula. Remember your starter. K plus 1, NO3 1 minus, so 1 1. So this correct formula. So we get this salt, and this is potassium. It's equally important to write the name from the formula, potassium nitrate. Okay, double plus, outside of the box, H plus H and O means again water. So usually water is formed as a byproduct in every acid-base reaction to give salt. We get salt and water most of the time. Okay, so this is also balanced exactly, nothing. So the equation is balanced. Now go to C, 2, this is 2, right on 2. Now let us go to the third salt here. And the third salt is, go to the board and check here. Just now we did potassium nitrate, now aluminum chloride. So right there, Al3 plus Cl chloride, 1, so no need to shift. These 3 at the top of Al can go to the lower backside of Cl, so AlCl3. As we said, the acid comes from the negative part Cl minus, so that is only acid having HCl, common one is HCl. Hydrochloric acid, so write that one. The acid is hydrochloric acid for sure. We can easily, that means we can easily know which is the acid used by looking at the negative part of the salt. And the positive part of the salt, Al3 plus, give you the clue for the base. And the base here is, of course, aluminum containing is aluminum hydroxide. Now you know from your starter, aluminum ion is 3 plus, so the 3 will shift to the lower backside of OH. Only after a bracket, because hydroxide is a compound ion. By that we mean it contains more than one atom. You see here, one oxygen atom, one hydrogen means 2 atoms are there. So if it contains more than one atom, that ion is called, this ion having charge is called compound ion. Okay, compound ion. Simple ion means it contains only one atom. For example, Na+, it has only one atom. Here 2, oxygen, hydrogen, right? So, and the number you are bringing down is greater than 1, then we need to put bracket before you bring. If it is 1, no need to put the bracket. Greater than 1. So this is your base. So this is aluminium. Okay, aluminium hydroxide. Now listen carefully to this, and we will get what salt. This positive and negative will give you the clue for the salt. Aluminium, Al and Cl means the only possible compound is right a little bit below the arrow. Aluminium. Remembering your starter, we know that it's surely going to be aluminum chloride. If you have memorized your starter, you know there is no other possibility. So use this name and write the formula. Al3+, and chloride is Cl1-. So 3 and 1 need not be shifted. 3 will go to the lower backside of Cl, and no bracket because Cl is not 2 atoms, it's only 1 atom. C capital small l signifies chlorine atom. Even though there are 2 letters, it's not 2 atom, it signifies 1. So no need to put bracket because this is a simple ion. We shouldn't put bracket in fact. Here we need to because there are 2 atoms, oxygen, hydrogen. Here only 1 atom, chlorine atom. Means simple ion. This is compound, more than 1 atom. Okay. So this is the salt. And then we know the byproduct without thinking too much. We just write down water because most acid react with base to give. Always will give salt and most of the time water. In few cases water is not given, but no need to bother because most of it give water. Now this equation we cannot follow the box technique. We have to really balance it by following principle of atom conservation, which says what? Yes, the number of each atom on left side, total number of each atom on left side should be equal to total number of the same atom on the right side. Let us start with one example. H is the first, or let's see here. And then bracket means this 3 belongs to both this H and O. If there was no bracket, 3 would belong to H, but 3 will not belong to O. That's why we needed to put a bracket. Now 3 ones are, no number means here 1. 3 ones are 3H plus 1H is how much? 4. So there are 4 hydrogen on the left side. How many H is there on the right side? Do with your pencil, okay? So you'll learn. Yes, how many atoms are there will be given by the back number, not the front. For example, this number of O is not this 2, it is at the back. Is there no number, so 1 atom. Here at the back of H2, so this belongs to H, does not belong to the next one. If a number is right in front, it belongs to everything, but at the back belongs to the one front, okay? So here now, there are 4 means only 2 and no H here, so to balance it, do with your pencil. Slightly bigger than this subscript. This is called subscript, means small letter, small size, and this one main. Now we are not allowed to balance from middle or back. Right in front we have to balance. So 2 2s are 4, now equal with H on the left side. So 2 2s are 4. Once you put the main script in front, that number will belong to everything after that. So it belongs to O also now, okay? So now, 4 4, balance H, so let's go to Cl. Now, before we proceed further, let me remind you this one. The only way to learn to balance chemical equation is to practice and listen. And the only technique that is endorsed is trial and error. Trial and error means kuribi, mistake kurisile rab kuribi, or try kuribi, then you learn along the way. And if you have done sufficient practice, there is, I think, no chemical equation that is going to be so hard. Majority 70-80% is quite easy to balance. And then few of them you may need a little bit of extra practice, but they are also not so difficult. So the only technique is by trial and error. Now we may learn different methods from different teachers, which is good, but in the end it's trial and error. You have to put it to practice, okay? And then you will get comfortable with it. Now I guarantee you it's not difficult. Now Cl1, no Cl, so only 1. Here 3, you see, and no Cl. So 3 here belongs to Cl, not to Al, okay? So 3, the one back belongs to one front, okay? The one front, right front belongs to everything. Now Cl3, only 1. So the only way to balance is, we are not allowed to balance from the back like this, wrong. Here also we cannot put wrong. Only way we have to balance is right in front, as I did here. So right in front you put 3, ones are 3 Cl to match with this 3. There is no Cl here, so there's no balance. The moment you do that, H is disturbed. That's why I'm saying trial and error. Now 3Cl, Cl3. So Cl and Cl done. Now go back to H because H is disturbed. 3H here, plus here, 3 ones are 3. So now it has become 6 because of the 3 that is put here. So we have to do something here. Now 2 2s are 4 is not going to work. We rub out with our rubber and write here 3. That's why I knew this is 3, but I just intentionally wrote there 2 to let you know that we learn by practice, trial and error. As you do this, you'll get so comfortable with it, you'll have no problem. Now 3H plus 3 is 6, then 3 2s are 6. Now H is also balanced, Cl balanced. 2 atoms are balanced now. H gone, Cl gone. Now let us go to Al. Al here at the back, yes, no number, 1. These 3 belong only to these 2 brackets inside, okay? Here also 1, so that is Al is balanced now. O is the one only left, so 3 ones are at the back of O, no number means 1. No? Yes, 3O, so here we have 3O on the left side. There is no O here, that's why I'm saying we are saying 3O on the left side. How many are there on the right side? 3 ones are, this 2 doesn't belong to O, 3 at the back, 1. 3 ones are 3O, here also 3O, so it's balanced now. So this equation is totally balanced. 3H, check once more, plus 3 is 6H. 3 2s are 6H. Now go to Cl. 3Cl, no Cl here. Cl3, balanced. Al1, Al1. O3, no O here. 3 ones are 3O, so it's balanced. So how would you read this equation? Let us try. 3 molecules of hydrochloric acid. Molecule means more than 1 atom. There are 2 atoms, you see. React with 1, no number means 1, okay? 1 molecule of aluminum hydroxide to give you 1 molecule of aluminum chloride salt and 3 molecules of water. That's how you will read the equation, okay? So this is called balancing equation. Now every atom on the left side, each atom is equal to the number of the same atoms on the right side for each and every atom. That is called balanced chemical equation, and we do that by following the principle of atom conservation. Okay, now let us go to the next, number 4, and the number 4 is here. We'll do slowly, so we'll learn to balance. You have to keep on practicing it sufficiently, it will become so easy. Number 4 is now, just now we did aluminum chloride. Let us go to zinc sulfate. Zinc sulfate formula from your starter, if you remember, Zn2 plus SO4 2 minus, so 2 cancelled. As we said, the acid comes from the negative part. So this one, the only acid having SO4 radical is H2SO4, which is sulfuric acid. So you write that one, sulfuric acid. Okay, and react with the base comes from the positive part of the radical Zn2 plus. The only base that can connect to that is zinc hydroxide. So Zn2 plus hydroxide OH1 minus, so 2 will go to the back. The way to write this one easily is to know the starter, the ions. Okay. Now, writing the name is, even if you don't write this name, if you write this equation formula correctly, you will get full marks. But I will encourage you to write the name, because once you learn to write the name and both formula and name, you become so confident, okay, in handling it. So zinc hydroxide. Now, which is the salt form? No need to memorize, as I said. Clue come from positive in the base and negative in the acid. So that only if you remember the starter properly, that's why knowing the starter has so much advantage. It will help you to form the formula without memorizing it, and know which compound is even going to form on the right side in most of the chemical reactions. So Zn2 plus SO4 2 minus means the only possibility is zinc sulfate. So you will be able to write this one confidently and saying this salt is surely zinc sulfate. If you know the starter properly, you will do that, and you will not be memorizing zinc sulfate. You will know from looking at the left side if you know your starter properly. So let us use the starter and write the formula now. Zn2 plus SO4 2 minus. So 2 cancelled. So this is the salt. And then we know without thinking so much, most of the acid-base reaction will give you the byproduct. Means the byproduct means not the main one, but the side product, water. Then the main product is the salt. Acid plus base against salt and water. Now, next job is to balance. So it's not so difficult what is on the right side, which compound, which salt and water. The main thing you need to do is balance. So let us do that. Hydrogen, how much here? Yes, 2. Plus 2 ones are 2. So how many hydrogen? 4 on the left side. Right side? Only 2. No H here. So put your pencil, try putting it there. 2 2s are 4 now, equal. Hydrogen is done. Now let us go to the next one. Sulfur, 1. So sulfur is left side 1. How about right side? No sulfur here. Here also 1. So far balance. O how much? 4. And here 2 ones are 2. So 6 O is 6 on the left side. Right side, left hand side, and right hand side. If you want to follow this. After you sufficiently practice, you don't even have to write this. Okay. By now, if you want, you can write it. Okay. 6 and then right side. 4 here. And then 2 now belongs. One main script in front belongs to everything after that, right? These 2 belongs only to H, but these 2 in the right in front belongs to everything. Every atom following it after that on the right side. So 2, no number here, 1, 2 ones are 2O and 4O. So here also 6. So here, if you want, you can make a table like this if you want. And then follow it up like this if you want. Okay, if it helps in the beginning. But as you keep on doing, you don't need even this one. 6, there also 6 now. O is done. H done, S done, O done. Zn is left. So write down Zn. Here, Zn. How much on the left side? 1, yes. Right side, 1. So here also 1, right side also 1, balanced. Then O is done, H is done, everything is balanced now. So this is how you balance. So the equation, okay, you can check once more. H4, 4, right. S1, S1 both sides. O4 plus 2, 6. 2 ones are 2 plus 4, 6. Zn1, Zn1. O done, H done, everything is done. So this is balanced now. So let us go to the next one. The next one is number 5. 2 more equations are there. Okay, B, balancing chemical equations of the acid-base reaction in these salts, of these salts. So 5. Now we have done zinc sulfate. Now let's go to sodium acetate. This is important. This is very easy, I think. Sodium, if you want to write, acetate. And from this formula itself, you can write the name. CH3, COO minus is acetate ion, and sodium ion Na plus, both valency 1. As we have learned a few moments ago, this is the only compound which has positive back and negative front, exception. Most of the compound have positive radical front, but this is having positive back and negative front, exception. Okay, so here, as we said, the acid comes from the negative part. So the negative part is not back, this one CH3COO minus acetate ion. So to this, the only acid having that negative part is CH3COOH, and we know this is called acetic acid. Okay, acetic acid. So this acid will react with this base come from positive part. The only base having that formula is NaOH. Now you may put AQ at the back to indicate it's dissolved in water. Here also, because bases and salt acids have to be put in water to release the ions. Only then they can act as acid or base, right? So here now here nothing to balance. Okay, it's just follow a trick. Mark the positive, as we said, in every case we can do this, I told you. And the negative, CH3COO minus is negative. H is positive, not H plus, hydrogen ion. So connect these 2 boxes. As we said, this is the only case where we write negative first. CH3COO minus and Na plus, exactly fitting, and we know this is correct compound because this is, but writing the name, we always write positive first, sodium, and then here, this radical is called acetate ion, so sodium acetate. Everything box exactly fitting, and outside the box HHO means H2O. So nothing extra, whatever is on the left side the box is fitting, outside the box is exactly fitting. So even they don't even have to try this, it's balanced, right? So that is 5. And the last chemical equation that you're going to have to do is number 6. And that one is here, sodium carbonate. So sodium carbonate is formula. Okay, if you want to write sodium carbonate. Okay, the formula is Na1 plus CO3 2 minus. So 2 will go there. Okay, so now the acid will come from which part? The clue, the idea? Yes, negative CO3 2 minus. The only acid having that is carbonic acid, H2CO3. This should be easy because the first question in video 7 was writing the 6 common acids and bases. So very easy, right? So here you write down carbonic acid. So this acid will react with which base? Idea comes from the positive. Yes, positive is Na+. The only base having Na+ is NaOH dissolved in water. So the base is sodium hydroxide. So here the acid, sodium carbonic acid, reacts with the base sodium hydroxide to give you hot salt. As we said, we've been telling again and again, no need to memorize the salt. Very easy to get a clue. Positive, negative combined, then the only salt positive, if you know starter, then this is going to be very easy. Na+, CO3 2 minus means just below there already read sodium carbonate. Okay, sodium carbonate. So write the formula Na1 plus CO3 2 minus, so 2 will go there. Surely this is the salt. Then the other one, without thinking, you just write, because most acid bases give the byproduct water. Now the main job is to balance. So let us balance. You can use the same table like this, left hand side and right hand side. Okay, if this helps you. Now here, this is the previous equation, so let us rub it out. Take the first atom here, H is 2 and here 1, so H is 3 on the left side. 1, 2 and 3. Here H is 2. Here H right hand side is 2. So it's not balanced at all. Just wait one moment and go to the next. It's better to do like the C1. Here also 1. So C so far 1, 1. So balanced. O 3 plus 1, 4. This side 3 plus 1, 4. So O is balanced. Then this one will give you the main touch that will start to balance the rest. Okay, Na 1. So you write here in this place Na sodium atom 1 on the left side, but there are 2 on the right side. So to make this one equal, first you put here 2 Na, 2 Na. Now this is balanced. This will trigger and balance the rest also. Just wait and see. Now how many, go back and see how many H now? 2 and here 2. So now this is this with your rubber so that you can rub it out. Okay, now 4 now. 2 plus 2 ones are 2, 4. Right side, also make it 2 2s are 4. Now both are balanced. H. Now go to C, 1. Here also 1. That's okay. So far balanced. O 4. Here, wait, O 3 plus 2 ones are 2, 3, 5. O is 5 now on the left side. How much O on the right side? 3, and then 2 ones are 2. This 1 at the back means 1 oxygen. 1 into 2 means 2 oxygen. Plus 3, 5. So it's O is also balanced now. Now Na 2, right side also 2. So every atom, the atoms on the left side are H, C, O, N, which are exactly the same atoms on the right side. You will not get any new atom in a chemical reaction. Then what types of atoms are there on the left side? We will find only that same type of atom on the right side, that is chemical reaction. And the number of atoms should also be equal. Now it's equal everywhere. So this is a balanced chemical equation. So now go and take TEST-2D, which is primarily writing the acid and the base from the salt, looking at the salt by getting idea. The acid comes from the negative part, base comes from the positive part, and these 6 equations. So if you learn to balance, then you can take the test. It's quite easy. Just go through question number 65 to 71 and you'll be okay with this. Okay, so that concludes the video. Okay.